Glycerol dehydrogenase or GDH is the enzyme for the substrate glycerol, whereas diol dehydrogenase is the enzyme for 1,2-PDO. GDH is COB12 dependent or vitamin B12 dependent enzyme. For the GDH research activities, statement A through C has been outlined. According to Talarico, year 1990, Salvaged, year 2002, and Daniel, 1998, various forms of glycerol dehydrogenase has been observed with the affinity at various pH has been outlined in the statement. 1,3-propanediol PDO has the formula structure as shown in diagram A. The isomer 1,2-propanediol different in the position of OH. 1,2-PDO could be further classified into D and L form with similar molecular weight of 70. Diagram B shows the product of 1,3-PDO able to form high-quality polymer. Physical properties of 1,3-propanediol are clear, odorless, colorless, innocuous liquid, miscible with alcohol, water, and ether. Synonyms of 1,3-PDO has two been shown in this chart. Types of chemical synthesis of 1,3-PDO and disadvantages are shown. Namely, 4 types of processes could be compared: Negusa, shell, glycerol dehydration, and ethylene dehydration. The operational cost of the production of 1,3-PDO is shown, and the formula is X by Gy, where X is the operational cost, Y is the cost of raw material, G is the market price of glycerol. The advantages of chemical synthesis of 1,3-propanediol or PDO are fast reaction and high productivity. This is the Chinese language version for 1,3-propanediol production. 13.20的研究进展。The translation is that 1,3-PDO is a type of fine chemical useful as the precursor of high-quality polymer. Due to the limitation of chemical synthesis, more economical biotechnological methods have been applied, especially through fermentation process. In the field of research and development, more effort has been placed on the expression of 1,3-PDD or propanediol dehydrogenase and the search for microorganisms that are able to produce high-quality polymer via the enzyme. 1,3-propanediol dehydrogenase PDD has EC number 1.1.1.202 with synonyms 1,3-PDD, 1,3-propanediol oxidoreductase, or 3-hydroxypropanaldehyde HPA reductase. There are various types of activity catalyzed by 1,3-propanediol oxidoreductase, namely the conversion of 3-hydroxypropanaldehyde to 1,3-propanediol and the conversion of propanol to 1-propanol. The trend for the development of 1,3-propanediol dehydrogenase has been outlined. Johnson and friends in 1987 used Klebsiella pneumonia as microbial source. Daniel and friends in 1995 used Citrobacter fluidi as microbial source. Tallarico and friends in 1990 used Lactobacillus reuteri as microbial source. Varga da Cunha in 1992 used Lactobacillus bucheri and Lactobacillus brevis as microbial source. Malawi in year 2000 used Clostridium pasteurinatum as microbial source. There are totally 5 stages to purify 1,3-propanediol dehydrogenase. Stage 1 is the growing of cells in aerobic and anaerobic conditions. Stage number 2 is centrifugation and precipitation. Stage number 3, gel filtration and elution by buffer. Stage number 4 is pooling of enzyme and elution of enzyme with buffer. Stage number 5 is using ion exchange chromatography. For aerobic enzymes, the specific activity was 10 units per milligram, whereas 35 units per milligram for anaerobic enzyme. The reference is Tabisco 1994. The literature review of Acidovorex has been outlined in this slide. The photo on your right is Acidovorex strains. Initially, it's grouped under Pseudomonas genus. Due to evolution, its multi-generic features reclassified it as Acidovorex according to Woese in 1987. Various types of Acidovorex are available as shown in the list over here. Characteristics of Acidovorex in King's medium: produce circular, slow-growing white colonies that are non-fluorescent under near ultraviolet light. The pathogenicity of the Acidovorex is outlined by Brand in 1999. This slide, in fact, has been presented in both languages, Malaysian and Indonesian languages on the left and English language version on the right. All Acidovorex can grow at 30 degrees Celsius in the presence of 0.5% sodium chloride or in the presence of the carbon sources like L-glutamate, L-proline, DL3-hydroxybutyrate solely. Hu 1998 and Pitt 1995 had done investigation on the antifungal characteristics of Acidovorex on Rania strains and others. The slide shows the typical growth curve for x-axis. Time hour is used, whereas for y-axis, log number, growth rate, temperature, and lag time are presented. Complex model is normally used for typical growth curve plot. There are 3 advantages stated here. Number 1, lag phase is not always horizontal, and equation is austere to negative during the decimal points growth. Number 2, exponential growth curve is determined by the inflection point. Number 3, the equation is continually curving and does not contain linear sections normally available in growth curve.